Good afternoon to our First in Texas teams and students. Welcome to our inaugural First in Texas Tech Talks. Today's session is targeting our first robotics competition program. My name is Susan Ashmore and I'm the Development Director at First in Texas. LabVIEW software for FRC provides components that help FRC participants program robots with LabVIEW. LabVIEW reduces the complexity of programming so you can focus on your unique engineering problem. LabVIEW enables you to immediately visualize results with built-in drag and drop engineering, user interface, creation, and integrated data viewers. LabVIEW software for FRC is a built software suite that provides software components required to use the LabVIEW programming language. This suite includes LabVIEW Professional, as well as software add-ons such as the LabVIEW Real-Time module and the LabVIEW Vision Development module. LabVIEW software for FRC also includes associated drivers. Today's expert is none other than April Riddett from National Instruments. Many of you know April volunteers for FIRST as a FIRST technical advisor at FRC events. We hear many teams ask her questions on debugging LabVIEW at events, so she is sharing her knowledge today to help you with your robot. April is a product manager at NI and has a degree in electrical engineering. And she is a recent UT McCombs MBA graduate, so hook 'em horns, April. After graduating from Rose-Hulman Institute of Technology, she joined NI's Engineering Leadership Program. April is also a mentor for FRC Team 5052, the Robo Lobos. Today's session will address what information is available on the driver's station, what does this information tell me about my robot, and how do I troubleshoot my robot with the driver's station. So April's prepared a slide deck for you. I know today's session is going to be very informative. April, are you ready to take the show?
Yeah, let's go for it. Awesome. So thank you for the introduction, Susan. I really appreciate it. I'm super excited to be doing this talk today. So we're going to be talking about something that's built in LabVIEW. It runs on LabVIEW, but it is not LabVIEW itself. And so what we're going to be focusing on is actually the driver station. So let me share this PowerPoint. Awesome. So I work at NI, big surprise. And today we're going to be talking about troubleshooting using the driver station. As Susan said, I'm a product manager at NI. Most people classify me as a serial FIRST volunteer, and it's really what I love to do. So the goal of today's session is really to look at what is the driver station, what information is in it, what tools exist in it, and go through some troubleshooting tips and examples that will hopefully help you debug your robot faster at a competition. So most of you are probably familiar with what the driver station is. For those of you who maybe aren't on Drive Team or haven't seen this before, the driver station is the robot control utility for practice and competition for all FRC teams. This is what we use to talk to our robots. This is how we communicate with them, whether it's over a cable from our laptop directly, whether it's via Wi-Fi that the radio is generating, or whether it's on a competition field. So what we're going to do is go through the whole driver station from the top, make sure that we kind of have the basics down, and then we'll get into some of the weeds on what we're looking at and how we debug with it. So when you open up the driver station, this is what you see. This is what you see. This is it. And so we have 5 tabs on the left-hand side of your screen, starting with the Operation tab on the top. And the Operation tab gives you the options for changing mode. That's where you enable and disable your robot. It also provides you with some information on your PC battery, which is always a good thing to check before you come to the field, and your PC CPU utilization percentage. As well as that toggle that I have highlighted there puts you into windowed mode or into full screen mode with the dashboard on top and the driver station on the bottom. There are 4 modes that the driver station can be in when you're not connected to the field. So when you're at home in your own shop or testing in the pits around the practice field, you have 4 modes. Teleoperated mode runs your robot in teleoperated mode. Autonomous mode, when you click the enable button, it will start running your autonomous code. use with caution. Your robot will do autonomous things. Practice mode, which is more of a let's test some stuff out. You can customize the times that things run in practice mode. And then test mode actually runs a practice match. So you can see how your autonomous transitions into the teleoperated period. So that can be really useful if you're noticing that your auton is doing something weird when it transitions into teleop period, or if your teleop isn't coming up right away when that buzzer sounds, that can be a useful mode to use. The next section of the driver station is what we call the robot information section of the robot info session. This tells you a lot of things about what your robot is doing at that moment in time. So in this case, you can see that I am simulating a robot. I am pretending to be team 2468, and all of my lights are green. So we have 3 lights, 3 indicators there: communications, robot code, and joysticks. What these 3 lights tell us is, do we have all of the pieces needed to enable our robot? And you're not going to be able to toggle that enable button until all 3 lights are green. The communications button goes green when your robot is either directly connected, so your RoboRio is directly connected to your computer, or it's connected over a radio or Wi-Fi connection. So once your computer can see your RoboRio, that communications light goes green. The robot code light goes green when the computer can see the RoboRio and is running code. If your code is crashing or you forgot to deploy the code, that light will be red and you will not be able to enable your robot. And that third indicator is the joysticks indicator. That just tells us if you have joysticks plugged into your driver station laptop or not. So if your joysticks are plugged in, you've like run out to the field, you've put your driver station on the platform, and you forgot to plug the joysticks in, that light will be red and your robot won't finish connecting. The last thing I want to point out in this view is on the right-hand side, we have an additional 3 tabs. And this alternates between message mode, graph mode, which you'll see on the next screen, and combo mode. So messages mode, if my robot was returning any messages, I would see them in this empty gray box. Since I don't have any messages, I don't see any. So the next tab down is the Diagnostics tab. This tab tells us a lot of information about what my robot is doing right now in terms of network connectivity. So this tab is really, really useful when you're trying to connect your robot, whether you're trying to connect it to a new Wi-Fi or to a new laptop or on the field. It tells you a lot of information about what the robot can and can't connect to. So you can see that underneath the communications heading, there are a whole list of things. And those different pieces are different components of the wireless connection system that the robot talks to. It's fairly complicated. So what's really nice is if you get into the driver station and mouse over those different titles, it will actually give you more detail on what that is and how you troubleshoot those specific issues. So I encourage you to go check those out. The one thing I did want to point out is we have this handy little button next to the communications title. We don't really have a good name for it. I call it the IP config release, IP config renew button, because that's what we used to go into command line and tell Windows to do before we added this handy button that does it for you. So if your robot just doesn't want to connect for any reason, sometimes clicking that button is a good troubleshooting step. It'll take about 30 seconds to reset your kind of the internal workings of your computer's IP and kind of renew them and get a fresh start. The other thing this tab really tells us is software versions. So a lot of times an inspector will have you bring up the driver station and go to this tab when you're doing your inspection, because the software versions will show up here as well. And so that's how they make sure everything is current and up to date. You can also easily reboot your RoboRio or restart the robot code from the dashboard. So rebooting the robot Rio essentially turns it off and turns it back on again, whereas restarting the robot code restarts the code. It doesn't actually turn it off and turn it back on. So the third tab, we're just working our way down, is what we call the setup tab. So here's where you will set up what team number you're on. So your team number should go where that 2468 is. Your dashboard type, if you're using shuffleboard or smart dashboard or the default LabVIEW dashboard, you can click that drop down and toggle it there. There is a game data field here. And this is the field where when the FMS returns data, like it has in some games, it does in Infinite Recharge, and it did in Power Up as well, that game-specific data will get printed out there. And that's how we know exactly what the field is sending you. The other neat thing about the Setup tab is you can configure your own match settings here, which can be kind of helpful when you test Auton into teleop, but you don't really want teleop to run for a long time. You can change those settings there and kind of develop your own match length if you want. The other thing we have up on this page is chart mode, which is some charts as opposed to some error messages. We'll do a little bit more digging into those charts in a minute. Fourth tab down is your USB devices tab. It might as well be known as your joystick tab because those are the only USB devices we really use in FRC. You'll see your joysticks show up in that USB order. And the really critical thing about this page is your joysticks need to be in the same order every time you drive your robot, or it's not going to talk to the right parts of your robot. If you've ever noticed that your robot feels backwards or things flipped, that could be why. So it's good to know which number your joysticks need to be in case they get unplugged and replugged in and kind of reconfigured. The rescan button down there is also the look for joysticks button. If for whatever reason your joystick isn't coming up automatically, usually that button will find them. The other thing that this tab is really, really useful for is when you get a new joystick or you're setting up a joystick for the first time, when you plug it in here, you can actually toggle all of those indicators, the axes buttons on the POV, and it will light up depending on which buttons you're pressing or which way you have the joysticks pressed. So this way you know what outputs that joystick is returning. So like when for example, if I was looking at the left trigger, I would know that, axis number 2, an output from 0 to 1 is the left trigger. And that would be a decimal output because it's a slider bar there. And so that can be really useful to kind of figure out what buttons you want to use on your joystick and how to effectively apply those code. We're also looking at dual mode here, or messages and chart mode. Your chart gets really tiny, but it's pretty tiny anyways. So usually messages mode is what I would recommend leaving this in. And then the last one that we want to talk about is the Power and CAN tab. So what this tab does is it shows you some deeper information about your power system and about your CAN network if you have a CAN network. It's a trick question. Everyone has a CAN network. It just depends how much is in it. So what's neat about this tab is if your RoboRio has one of those red power lights that's indicating a short, you can come down to this tab, connect your RoboRio, and it will tell you which of the power rails your short is on. And so that can help with debugging, because if it happens only when it's on the robot, then we come to this tab and we look and we see it's on the 6-volt rail. Well, then we know it might be a relay, or it might be a sensor shorted that's connected to the 6-volt rail. We also have the CAN metrics here. So this just tells you your bus utilization percentage, whether the bus is on or off, and some further diagnostics about transmitting and receiving. Typically, you want to keep your CAN utilization around 80% or lower. If you're seeing a higher CAN utilization percentage than that, that could lead to some issues, but not always. So it's just kind of a good thing to come check if you're having weird response times with your robot, or if it's driving kind of laggy, it'd be a good thing to come check. Cool, so that's like the basic driver station. We've gone through the whole thing. That's everything you need to know to drive a match. Now where it gets interesting is that we have a whole bunch of tools that help you debug your robot better. And they help, the goal of these tools is to really help you understand why your robot is doing what it does and what causes it. And so part of these tools is when you right-click on this gear that's shown here, it's always in the message box. Excuse me. It gives you this drop-down. And so one thing you can do is toggle on and off whether or not you want warnings that the Roborio may generate or print statements to print into the message box. And so that's kind of the bottom 3 options on there. The clear option clears all the messages that are in the box, pretty self-explanatory. And the really interesting ones are view log file and view console. So we're going to start with view log file. Driver station log files. I love driver station log files. They are so incredibly useful. I can almost guarantee that anyone who's been on a drive team has seen the FTA or the CSA run over after something has gone wrong in a match and be like, oh, I'm going to look at your log files. And then they look at this and they poke some buttons and then they tell you, this is what is wrong with your robot. My goal is to help demystify that whole process, and hopefully you can go look at your own log files and be like, yes, this is what is wrong with my robot. So you get log files, right click on that gear, select view log file. This is kind of what shows up, is the screen. You'll have a whole bunch of selectable files in one box. Yeah, we'll go this one. You have a whole bunch of selectable files in one box. These are all of your matches and things like that that show up. Every time you turn on your Roborio, it makes a log file automatically. You don't have to do anything to enable this. It does it automatically. And so all of these log files will be stored somewhere on your driver station laptop, most likely at users/public documents/FRC/log files, because no one usually changes that directory. But if they do, you can see where the log directory is. It's listed under that list of files. And this will help you go through the matches that you've played and see what maybe happened. The other thing on that far left-hand side of the screen is the detailed message box. This box provides a ton of information about whatever you are mousing over at that point in time. So we'll look at that with a little bit more clarity later. But you can just hover your mouse over pretty much any portion of this graph, and more information will appear in that detailed message box. So the big star of this page is the match graph. And this graph is chock full of information, and it looks like information. So we're going to break it down and hopefully make it a little bit more digestible. If my PowerPoint will advance. Cool. So the match graph. The key things that you want to look at match graph are kind of what's called out on the left-hand side of the screen. We've color-coded things so that you can look at a bunch of different lines on this page at once, but it is a pretty busy graph. So looking at the graph legend, that yellow line is your battery voltage over time. It's literally just the voltage of your battery that the Roborio is reporting. Anything below 7 volts is pretty questionable. The operating voltage input range for the Roborio is 7 to 16 volts. Anything below 7 volts may cause it to enter some preemptive shutdown stages to safely turn off your robot if it does lose power. So we don't want to get close to 7 volts. Latency is shown in lime green. Oh, the other thing about battery voltage is it has its own axis on the left side of this chart. The axis is also in yellow. So that corresponds only to that yellow line. The rest of the graph corresponds to the white axis on the left-hand side. Clarifying point. So latency, it is shown in lime green. It should be at the very bottom like it is in this graph. If your latency is high, that's how long it takes the packets to go from your robot through the radio to the FMS to your driver station and then back. That should be really quick. It should be happening really fast. If you're seeing large latency spikes, that could be leading to your robot being laggy. Same with the packet loss percentage. That's kind of that orange bar you see on the bottom left-hand side of the graph. There will usually be a spike in packet loss when you first connect your robot and when you disconnect your robot, just kind of due to the way the network shakes out. But this should be pretty much non-existent too. Usually when you see your latency spike, you're going to see your packet loss spike too. They kind of go hand in hand. The red line is your RoboRio CPU usage percentage. And this is literally just what percentage of the RoboRio CPU are you using. It's just like a computer CPU. And just like the computer CPU, you don't want to use 100% of it. The sweet spot is again around 80%, 80 to 85%. You can push it up to about 90. Anything over 90 gets kind of questionable because it needs that remaining portion of the CPU to be able to execute any safety shutdowns were an event to occur that would necessitate a safety shutdown. So we don't want to get into that. So 80 or below, you're in the clear. What's neat about the RoboRio CPU usage, and you see it in this graph, is that it spikes sometimes, and that tells you when you're using more CPU. So for example, if I was running a vision tracking system on my RoboRio, and every time I pulled the left trigger, it did the vision tracking, I would be able to see the little spikes in my CPU usage every single time I pulled that trigger. So it can be a really good way to make sure that everything you think is happening on your robot is actually happening on your robot when you think it's happening on your robot. And then the last one I want to point out here is CAN bus utilization percentage. This is another place to see it. This is where you can see it plotted against time. And again, it's just what percentage of the CPU, of the CAN bus are you using? My apologies. Okay, and then I want to focus in on this little area at the top of the graph because there is like a lot of information in like a ½ inch of screen. Perhaps most importantly, I don't say most importantly, one very important thing that is up here are what we call the state bars or the mode bars. And there are two here. They should be exactly the same all the time. But the top bar represents the robot or the RoboRio, and the lower bar is driver station. And this tells you what mode they are in, whether they are disabled, e-stopped, teleop, or autonomous mode. So autonomous mode is that green section of line, and then teleoperated is the blue section of line. So for every match that you play, you'll see these at the top, and there will be 15 seconds of auto, and then the 2:15 of teleop. So that can help you to reassure yourself that your robot's in the right mode. It's really useful for testing. If you expect it to be in a certain mode and then it's behaving weirdly, you can check and make sure that it's in the right state. The green and yellow dots that you see here that are all in a row, these represent messages coming from the RoboRio. These could be warnings, these could be errors, these could be print statements. But this is one of those things that you can hover over and get more information in that detailed message box here. So we hover over those green dots, we get information in the detailed message box. Lastly, the orange X's. These represent errors. Almost always they're brownouts, and we're going to talk about brownouts later. But again, you can mouse over them to show more information about these errors. The other thing in here is the driver station console. And you can get to the console one of two ways. You can right click and say view console, or you can if you have the log file viewer open already, you can click on that event list that I have in an orange box here. That will tell you all of the messages that went to and from your robot and anything that was reported at any point during the match. Warnings will be this beige color. So you can see that first warning, 44003. I don't have any code on my robot. That's a good thing to know. That should be a warning because I'm not going to be able to drive my robot because there's no code. So those kinds of things are useful. And then you see that there's an error because there's a call library function node in C tier, blah, 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 blah. Basically, when we read through this error, you can say, hey, it says, have you installed Phoenix on the RoboRio using tuner? I had not. And so I would go, oh, maybe that's why my motor controllers were working because I didn't have Phoenix installed on my RoboRio. So I would go and fix that and then hopefully not get this error the next time I opened up my RoboRio. So you can learn a lot of useful things in here. I recommend you go through the console when you have errors that are showing up in your messages box on the driver's station. Those may go by pretty quickly there, and they will be preserved in the event list. So that is a massive download of information about the driver's station. So we're going to go through some troubleshooting tips and examples, and we're basically going to take 3 scenarios that I see all the time as an FTA and show you what I'm looking for when I'm trying to decide if your robot is experiencing this issue. I'm going to try to keep my voice from disappearing. So, the eternal question. Why did my robot stop working during a match? There's 3 main reasons. It could be electrical, it could be mechanical, or it could be a software problem. That's pretty much all the issues. That's it. That covers everything that could possibly happen to your robot, barring natural disasters. That's a lot of options. So the driver's station can probably tell you where you should start looking. And so we're going to use the driver's station kind of like a map or a guide to understanding your robot's emotions and feelings after a match. This is what you want the driver's station to look like when you're connected, you're having a match. This is what you want. It'll show up as enabled, obviously, but I don't have a robot here. So bear with my interesting paint job that you can clearly see. I have edited some values here. I don't have a robot. I'm quarantining, so we're going to go with the paint job. But this is what you want. Those green lights, that battery indicator should be green. It should be giving you a value that's somewhere north of 11 volts. At the start of a match, 12.5 and higher is usually good. And there should be no messages. Your team number should be there. Everything looks great. So what we're going to look at now is driver stations that don't look like this, because that's when your robot is sad. So scenario number 1, we have this is our driver station. I'm driving along and I look down and this is what I see. My robot is behaving erratically. It's not really driving right. I, go to engage in a pushing match with a robot and my robot just kind of sputters and doesn't actually push. I may be losing connection with my robot and it might come back after about 20 seconds. The RSL, the robot's signal light, may be flashing or flickering weirdly instead of doing the metered flash. But most importantly, this battery indicator does not look good, right? The battery is yellow. It has a red box around it. There will literally be a red box around it. And it's a 6.2 volts. What do we think could be happening here? What's one possible scenario? So typically when we see this behavior, and we see this a lot, it's called a brownout. And a brownout occurs when your robot battery cannot provide enough voltage to keep the RoboRio alive. There is a finite amount of power in your robot battery. Very quick electrical engineering lesson. Power equals current times voltage. As your current draw increases, your voltage has to decrease. They're in a natural balance, and that's how electricity works. So you only have so much current and voltage that you can draw out of that battery at any given point in time. As you draw more current, that voltage level drops. Things that draw current are basically driving your robot, but using your motors. When you're really pushing your motors to their limit, that's when you're going to see the most current draw. So when you're engaged in a pushing match with another robot, if you're using really heavy effort mechanisms, so like for example, this year when your robot was trying to climb on the switch generator, or generator switch, sorry, that was one potential area where you would crank on those lifting motors. Or if something is mechanically wrong with the drivetrain, a motor is burned out, a chain is stuck, etc., that causes it to not function as it should and use up more of that current resource. I mentioned this earlier, but the RoboRio needs at least 7 volts to maintain its internal processes. That is kind of our cutoff limit for where we need to start safely shutting things down so that we can turn off the robot if like the battery goes flying out and it's suddenly powered off. We need to make sure everything shuts down in a safe state so that with the next time you turn it on, your mechanisms don't suddenly start flailing and things like that. So 7 volts is our sweet spot. That's where we start to enter those shutdown protection areas. So 7 volts and higher is a happy RoboRio. The other place we can really see evidence of brownouts is in the driver station log match graph. It's a mouthful. But in this graph, this is a beautiful example of a brownout. You can see that our yellow battery voltage line is dropping below 7 volts. You can see that we have a whole bunch of those orange X indicators. And if you were to mouse over one of those orange X indicators, this is the cutout in the lower right-hand corner of your screen is what you would see in that detailed description box. It says brownout. It tells you when it happened. And it also tells you how much amperage was being drawn out of the system when it happened. So 110.8 amps is what that third number is. So this is a really clear indicator that this robot is having some power supply issues. Probably, if I were to take a guess, it was probably playing some defense. It was probably pushing on something pretty hard. That's where you really see those repeated spikes on the battery voltage line. But this is a key example of what a brownout looks like in your match log graph. So I'm going to talk about this for a quick second because brownouts are something we see all the time. It's something pretty much every team ever has dealt with. And I want to talk to them for just a minute. I'm going to get on my soapbox for like a minute about brownouts. Why is my robot browning out? It's really easy to spot a brownout. It can be a lot harder to understand why your robot's browning out. One potential category of issues is behavioral issues. And I call them behavioral because they are really driven by the humans on the team. They are behavioral choices that lead to poor robot performance. And kind of a great way to sum this all up is when the strategy that the robot was designed for does not match the strategy that is being executed on the field. I have a robot that is designed to really manipulate game pieces and get from one end of the field to the other really, really fast, and I sit down and start trying to play defense, I'm going to be pulling insane amounts of current and brown out my robot. So typically behaviors that we see robots engaged in when they brown out are, you know, that pushing match with another robot when you're playing heavy defense or when you're receiving heavy defense. We also see it if you get stuck on a wall or a game piece or the field and you're attempting to free yourself, that can cause those current spikes too. Another potential category of problems is mechanical. Your drivetrain is damaged or misaligned in some way, if a mechanism is stuck or broken or misaligned, this can lead to the robot kind of fighting itself. And so you're really trying to pull power out of those motors to do something that, again, the robot wasn't designed to do. And so that's where we see some brownout issues come in there. Or if your battery isn't well attached to your robot and you start dragging it around behind your robot, that can show up as a brownout as well because that connection isn't tight. And that leads us to our third category of issues, which is electrical. And electrical brownouts really result from the power supply chain, that path that goes from your battery all the way to the RoboRio and back, so all the way on hot, all the way back on ground. If those aren't well secured, all of those connections should be really, really tight, or those can lead to brownout type behaviors. If your battery has loose terminals, so when I say terminals, I'm talking about that point on the battery where you take that bolt and crank the wire onto the battery physically, those should not move. Those should be rock solid because it only takes 1 second of voltage less than 7 volts for your RoboRio to reboot and go into brownout protection. So we want to have no seconds of low voltage. Related to what I talked about for mechanical, when the motor on the drivetrain is burned out or it's driving the wrong way and kind of fighting against the other motor, that can indicate a bad motor. That can lead to brownouts. Or if your battery is bad or has a bad cell, so one piece of your battery is bad. Batteries are made up of cells, and these cells have a specific chemical ratio, and if that chemical ratio gets out of whack as battery gets older, they don't work as well. You can check that with a battery beak. Really great little piece of equipment. And then I want to elaborate on the last point because brownouts are notorious. How do I know which motor might be damaged or wrong? I've been looking at this brownout. I think I have a bad motor. How do I know which one? Right after a match, the problematic motor is probably super hot. Be very careful touching motors. I say super hot, I'm talking hundreds of degrees hot. So be very careful. There are these handy little temperature stickers that you can put on your motors. Instead of burning your fingers, do that. But you can also use the driver station log file viewer to look at your match graph and see your motors. So on the right-hand side of the screen, I have highlighted, I just tried to click a mouse that wasn't there. I have highlighted this plots option here. And this area lets you toggle different graphs on and off to show up on this graph, different plots to show up on this graph. And one thing you can toggle on and off is every individual channel of your PDP. So you can toggle them all on like I have done here and look at them and see if one is really, really high. Usually if you have a bad motor, it'll be pretty obvious. I didn't have a graph with a bad motor readily available, so I don't have one to show you. But this is what kind of a normal graph looks like. And you can mouse over all of these as well, and they will return the value in that detail box in the lower left-hand corner. So I moused over this particular PDP 10 line here. It's that lime green, or sorry, PDP 14. It's that lime green, and it's telling me at 5:05 and 47 seconds and 35 hundredths of a second, it was drawing 35.1 amps. So really useful debugging tool. Just wanted to put that out there. Scenario 2, the other scenarios are much shorter. I'm really passionate about brownouts. Scenario number 2, I have this top one, is kind of what I see initially. And I'm looking at it and it says communications is bad because it's red. And so the first thing I do is click on the communications tab on the left-hand side. And I'm looking at this and this is what I see. So looking at all my little green lights on the left-hand side there, one of them is like very noticeably off. And that's my robot light. And so looking at this, there's a few different reasons that this could be. But basically it means I'm not talking to my robot. And so what this could mean is that my radio has no power. The communication light only goes green when there's communication going from the FMS to the radio, to the Robo-Rio, and all the way back to the FMS. From the driver station to the FMS first, but yeah. So radios can lose power due to a whole bunch of things, loose wires and connections, falling off the robot, or using the barrel jack instead of the PoE cable. I made a lit meme to relate to current students for what choice you should make in your radio power strategy. Yes, so all joking aside, the barrel connectors had their time and place. They were great. We have something much better now, which is PoE injection. PoE is power over Ethernet, and essentially that powers your radio, but it also has the security of clipping in on that Ethernet port. And so you put those two little terminals into your voltage regulation module, you plug the Ethernet end into your radio, and then your Ethernet cord goes from your Robo-Rio to that Ethernet jack there. It's a great solution. They're super cheap. I really recommend them. The other thing I wanted to point out here is when you're troubleshooting network connectivity issues, one thing you can go look for is your ping state results. This will be in the event list of your driver station log file viewer. So if we went, whoops, we'll click back up here. This is your event list, so reminding you, and we're looking at one of these messages. I'm going to go back to my slide. This tells you a whole bunch of information that really helps you troubleshoot those network connectivity issues. So there are 4 key things to check here. The first one, it says driver station radio. That is saying, can the driver station see the radio? You want that to be good. In this case, it's bad. When any of these say bad, that means that connection isn't there, and you need all of those connections there to start a match. So can the driver station see the radio? Robot radio is asking, can the robot see the radio? The RoboRio indicator is, can the driver station see the RoboRio? And then the FMS is, can the FMS see the RoboRio? So in this case, I wasn't connected to the FMS, so that's obviously going to be bad. And then I didn't have a radio plugged in. So those 2 are obviously going to be bad. But I was directly connected to my RoboRio over USB, so that's why I got the RoboRio ping back. Good. So just sharing that information with you. And then the last topic or scenario I wanted to touch on really quickly is, if this is my driver station and I'm trying to drive my robot around and it's being laggy, for lack of a better word, it's stuttering or it's not responding quickly, and I look and I see this. What's different about this driver station view than anything else is that now we have messages. I have simulated some messages. And I know that my mechanical team or my electrical team was doing some troubleshooting on our, I don't know, the position of our shooter. And they were putting in some print statements to know what position it was in when it was shooting. And so I'm getting all these print statements. There is such thing as too many print statements. It shows up usually as this very solid green line of dots, these message dots, but it often comes with high packet loss, which you can see at the bottom of the graph. And what having too many print statements does is it overwhelms your allotted bandwidth for communication, and it slows all of your packets down. When the packets are being sent, it's impossible to tell whether it's a message or whether it's a command or what is being sent. And so they all get kind of equal priority. And so they just send in a first in, first out type of function. And so as the packets are generated, they get sent. What happens when you're generating way too many packets is that your control packets, which are your joystick commands to your robot, get lost in the shuffle. And so these slow packets are leading to your robot being laggy. The solution here is to kindly ask your programming team to comment out any print statements that they were using for troubleshooting when you go to a match. They don't have to be removed, just comment it out. And this will enable you to drive your robot in a responsive manner, and then they can turn them back on if they need to do any further debugging. And that's it. I just dumped a ton of information on you. But we will be providing this recording and the PDF of these slides as well, so hopefully you find them useful in the future. I'm happy to take questions.
Very good. So we will get back with you First in Texas teams, and we will get back with April and put that content out there. So April, once again, you are a rock star to our first students and our First in Texas team. You make a difference in the lives of thousands of students over an FRC season. Stay safe, everybody. Goodbye.